RAG failure analysis usually begins after someone says, "But the answer came from our documents." That sentence sounds reassuring. It is also the mistake at the center of this episode. Connecting an AI system to your documents does not automatically make the system truthful. It gives the model more material. Whether that material becomes a correct answer depends on everything that happens between the user's question and the words on the screen. And when any part of that chain breaks, a useful assistant can become a confident liability. Picture a support team preparing to launch a new chatbot. The team has done what responsible teams are told to do. They connect the bot to policy documents, product manuals, and support articles. They give it access to the company's knowledge base. During testing, the bot performs beautifully. It answers the questions everyone expects. It finds the refund page. It summarizes the warranty policy. It cites the employee handbook. The answers are fast, clear, and professional. The team starts using a powerful word: grounded. The bot is grounded in company documents, so people relax. The launch dashboard is green. The demo gets applause. The system goes live. Then a real customer asks a question nobody used in the demo. Can I cancel after the free trial if I signed up through a promotion but never activated the account? It is not a strange question. It is just specific. It contains 3 conditions, and each one matters. First, this is a free trial purchase. That points toward the general cancellation policy. Second, the customer signed up through a promotion. That may trigger a different set of terms. Third, the account was never activated. Any one of these details could change the answer. Together, they make this an exception case. Behind the scenes, the system simplifies the question into something easier to search. Free trial cancellation and refund policy. The promotion and account status disappear. The bot finds the general trial policy, misses the exceptions, and writes a clean answer saying the customer can cancel for a refund. It even adds a citation. The customer follows the advice. Support later rejects the refund. Now the customer has a screenshot of an official-looking answer from the company itself. The problem is no longer that an AI made a mistake. The problem is that the mistake looked like policy. That is the incident we are going to investigate. By the end of this video, you will know where a RAG system can fail, why citations do not automatically prove an answer, and what your team should test before customers find the weak points for you. If you appreciate this type of production AI post-mortem, gently tap that like button. Let's open the case file. To understand the failure, we first need to understand why the design looked so safe. RAG or RAG stands for retrieval-augmented generation. The name is technical, but the idea is simple. Before the model answers, the system searches for information that may help it answer. That search can point to information the base model may not know, including private company documents or recently updated policies. Those documents can remain inside access-controlled company systems, depending on how the application is designed and operated. That makes RAG extremely useful. It also makes the result feel more trustworthy than an answer produced from the model's general training alone. The flow diagram has 4 verbs: ask, search, retrieve, answer. A user asks a question. The system searches the knowledge base. It retrieves a few document chunks, which are relevant parts of a document. The model writes an answer using those document chunks. When the right passage is retrieved and the question is straightforward, this works remarkably well. It can turn a mountain of internal documentation into an assistant people can actually use. But our support bot did not fail on the straightforward question. It failed on the exception. That is where useful and safe separate. Retrieval is not a truth upgrade. It does not transform a language model into a verified answer engine. It simply places selected text in front of a model that is still designed to produce a response. A RAG application is really 2 systems working together. The first system searches. The second system writes. The final answer can only be as reliable as the handoff between them. If search returns the wrong policy, the writer can make the wrong policy sound clear. If search returns an incomplete passage, the writer can smooth over the missing condition. If 2 documents conflict, the writer can blend them into an answer that appears in neither one. That is what happened in our incident. The model did not need to invent an entire refund policy. It only needed to receive an incomplete one and speak with more certainty than the evidence deserved. The citation made the answer look grounded. The confident tone made it feel settled. The company interface supplied the authority. Now we can reconstruct the failure. Every answer passed through a four-step pipeline. We are going to replay the customer's question through each step and look for the moment where truth was lost. Step 1 is the original question. Can I cancel after the free trial if I signed up through a promotion but never activated the account? Notice what the user is really asking. This is not just a trial question. It is a trial question with a promotion condition and an activation condition. Step 2 is the query rewrite. The system turns the natural language question into something it can search. In our case, imagine that the rewrite becomes free trial cancellation and refund policy. It sounds reasonable, but two decisive details have already disappeared: the promotion and the account that was never activated. Step 3 is retrieval. The system searches thousands of document chunks and returns the ones that appear most relevant. The general cancellation policy ranks first. A promotion FAQ ranks lower. The exception for unactivated accounts sits inside an older policy table that was split badly during indexing. The system found material about the topic. It did not find the complete answer. Step 4 is generation. The model receives the question and the selected chunks. It sees a clear general policy and no obvious warning that an exception is missing. So it does what the product asked it to do. It answers. This is why the demo looked magical. The demo questions matched the headings in the documents. What is our refund policy? Went directly to the refund policy. The test proved that the happy path worked. Production introduced everything the demo removed: vague wording, multiple conditions, outdated documents, edge cases, typos, copied email threads, and questions whose answers were not written down anywhere. The system did not suddenly become worse after launch. The questions became real. Our first failure point is the knowledge base. The investigation starts with a simple question: what did the company actually tell the system was true? The answer is usually less tidy than the launch diagram suggests. There may be old policies that were never retired, customer-facing articles that simplify the rules, internal notes that add exceptions, and PDFs whose tables turn into scrambled text during processing. The knowledge base may contain several versions of the truth, all searchable at the same time. Retrieval does not clean that up, it indexes it. If the source material is confused, the index becomes a faster way to find confusion. In our support bot case, 3 documents govern the answer. The general policy says refunds are available within 30 days. The promotion terms say promotional purchases are non-refundable. A separate account policy says unactivated accounts require manual review. A human agent would probably ask a follow-up question or escalate the case. The bot sees 3 pieces of text competing for attention. So the first root cause is not generation. It is source of truth failure. Before tuning the model, the team needs document owners, effective dates, version rules, permissions, and a clear method for resolving conflicts. Otherwise, the bot can produce a polished answer from policy debris. The second failure point is search. Even with perfect documents, the system still has to find the decisive passage for this exact question. Retrieval is a matching process. It may use keywords, vector similarity, metadata, re-ranking, or a combination of them. Those methods can be powerful, but they do not understand the customer's situation in the way an experienced support agent does. Retrieval can look relevant while missing the fact that decides the case. A keyword search can miss a policy written with different language. A vector search can return a passage that sounds similar but governs a different product. A metadata filter can quietly exclude the correct region or plan. A re-ranker can place the general policy above the exception. And remember what happened before retrieval even began. The query rewrite dropped promotion and never activated. The search system was not searching for the full question anymore. It was searching for a simpler question that happened to be easier to answer. This gives us the second root cause. Relevant is not sufficient. Finding a refund document for a refund question is not enough. The system must find the passage that supports the answer for this customer under this policy version with these conditions. If your evaluation only asks, "Did we retrieve something about refunds?" the system can pass the test and still fail the customer. Before we follow the evidence into the prompt, pause here and think about your own pipeline. If a user asked the ugliest edge case question you can imagine, would your search find the decisive passage or merely a related one? Check the description and pinned comment for the episode resources and diagnostic checklist. Now let's inspect what the model actually saw. The third failure point is context assembly. Retrieval may find several useful chunks, but the application still has to choose which ones enter the prompt, in what order, and with how much surrounding text. In other words, what does the model actually see? Should the prompt contain 3 chunks or 12? More context can preserve evidence, but it can also add noise. Should titles and dates be included? Should the newest policy outrank an older one? Position changes what receives attention. Should low confidence results be removed? Should conflicting passages appear together? These are not formatting details. They shape the evidence the model is allowed to use. The model does not see the company's entire knowledge base. It sees one temporary slice placed inside one prompt. If the correct exception remains in the database but is left out of that slice, then for this answer, it effectively does not exist. Even included evidence can be overlooked when it is buried inside a long, noisy context. Researchers often describe this as information getting lost in the middle. From the retriever's point of view, the passage was found. From the model's point of view, it was one signal among many. From the customer's point of view, the answer was simply wrong. All 3 descriptions can be true. This is why the citation did not save our support bot. The citation might prove that a document was present. It does not prove that every claim in the answer is supported by that document. The system can attach the general refund policy to a sentence about a promotional exception the policy never mentions. Without claim-level checking, a citation can become decoration. A genuinely grounded answer needs 3 things. First, the decisive evidence must be in the prompt. Second, the important claims must be supported by that evidence. Third, when the evidence is missing or contradictory, the system must stop pretending the answer is settled. That brings us to failure point 4. Answer pressure. The user asks a question. The interface expects a response. The prompt says, "Answer using the context." The model has been optimized to be helpful. Everything in the product is leaning toward an answer. So, the model gives one, even when the evidence calls for a question, a warning, or a handoff. This is where hallucination becomes a product decision. If a dashboard treats every refusal as a failed interaction, teams will push the system toward guessing. If the interface hides uncertainty, users will read the result as final. If evaluation rewards completeness more than correctness, confidence wins. But in a high-risk question, a correct refusal is a successful answer. Our bot should have said, "I found different rules for trials, promotions, and unactivated accounts. I do not have enough evidence to confirm your refund. I need one more detail, or I can route this to support." That answer is less magical. It is also far more useful than a confident mistake. Now zoom out from our composite case. The pattern begins when a system gives a confident answer and a person relies on it. Then the answer produces a real consequence. Once reliance enters the story, the failure is no longer contained inside the model. In the Air Canada chatbot dispute, a passenger sought information about bereavement fares. The chatbot described a path for requesting a refund after travel. The airline later argued that the chatbot's information should not make the company responsible. The Civil Resolution Tribunal rejected that position and held Air Canada responsible for the information presented through its website. The lesson is not merely that chatbots can be wrong, it is that automated guidance can become part of a customer's decision. In Mata versus Avianca, lawyers submitted court filings containing cases generated by ChatGPT that did not exist. The setting was different, but the failure pattern was familiar. Fluent output, borrowed authority, insufficient verification, and real consequences. The citations looked like evidence until someone checked them. The same danger appeared in reporting about New York City's My City chatbot. The tool was presented as a source of official business information, yet testing found answers that contradicted rules on worker tips, cash payments, and housing protections. Again, the risk came from the combination of confident language and institutional authority. NIST includes confabulation among the risks organizations should manage for generative AI. OWASP also warns about over-reliance on model output. These are not amusing quirks. They are production risks. So when an answer goes wrong, do not stop at the model hallucinated. Reconstruct the event. Start with the request. What did the user ask, and how was that question rewritten? Then inspect the evidence. Which passages were retrieved? Which ones entered the prompt? What supported each claim? Finally, trace reliance. What did the interface imply, and what did the user do next? That sequence turns a vague AI failure into an incident your team can actually fix. Here is the 5-question diagnostic checklist. Question 1. Is the knowledge base clean, current, owned, and permissioned? Question 2. Does retrieval find the decisive passage, not just a related document? Question 3. Can every important claim be traced to exact supporting evidence? Question 4. Does the system abstain or ask a follow-up question when evidence is weak? Question 5. Are you testing messy production cases, including conflicts, missing details, typos, and permission boundaries? If you cannot answer those 5 questions with evidence, the system is not ready for trust at scale. The mitigation stack follows the same path as the investigation. First, clean the documents. Add owners, effective dates, version rules, and access controls. Second, measure retrieval. Build a test set where the decisive passages are labeled, then check whether the system finds them. Third, verify grounding. Important claims should point to exact evidence, and the evidence should actually support the claim. Fourth, design useful refusal paths. Give the user a follow-up question, a clear limitation, or a route to a human. Fifth, turn incidents into tests so the same class of failure cannot quietly return. You can remember the operating loop in 3 words: ground, refuse, test. Ground every important claim in evidence. Refuse when the evidence is missing or contradictory. Test the situations where the system is most tempted to guess. Now return to the customer's refund question. The wrong answer did not appear from nowhere. The documents contained competing rules. The query rewrite removed key conditions. Retrieval found a related policy but missed decisive evidence. Context assembly gave the model an incomplete slice. Answer pressure turned that slice into certainty. The citation and interface made the certainty look official. The failure chain runs through documents, retrieval, context, answer, interface, and evaluation. Your documents are not enough. Your embeddings are not enough. Your prompt and citations are not enough. What you need is a system that can find the right evidence, recognize when evidence is missing, support its claims, refuse safely, and learn from failure. That is the difference between a RAG demo and a production AI system. But even a well-grounded system has another weakness. What happens when the documents it retrieves contain instructions designed to manipulate the model itself? That is prompt injection. The attack your AI application probably fails. It is the next production AI failure file, and you can watch it by clicking right here.